Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? Alright, today's video, I have a video request sent in by a subscriber. They wanted me to talk about how a sky ride works. So, let's get right into it.
Now get ready, here we go.
Alright, so normally what happens when I get suggestions from people is I try to generalize the subject. So someone will ask, hey, how does this one specific ride work? And unless that ride is something very unique, I don't really want to focus on the one thing. I want to more generalize it and say this is how that type of ride works. So it covers multiple rides on multiple installations. I can't get all the little nuances and things that rides have, but again, they're per installation basis, so that's a really hard thing to do. So on this particular video, someone asked me, they said, hey, can you do a video about how a sky ride works, or how the sky ride works over at Cedar Point? And I was like, sure. I was just going to do one on aerial tramways in general, because that's what Skyride is. It's an aerial tramway. So I started looking into it, and not having that much experience with aerial tramways, I really got into the subject and found out that it was an extremely vast subject, and that every single installation on every different type is dramatically different, with so many little crazy caveats and stories all over the place that it's like, okay, I can't generalize this subject. It's not going to work. So I started focusing in on just the sky ride, and that kept me quite entertained, honestly. I kept digging into it, and I was just like, wow, that's interesting. That's interesting. The more information I pulled out for it, the more intriguing it got. I was just like, yeah, okay, so let's do this. So here I am talking about the sky ride at Cedar Point. Now, the sky ride was built by a Switzerland-based manufacturer, Swiss-based manufacturer, called Vonroll. Vonroll actually had many of these attractions, and they are now being taken care of by a different manufacturer because the original Vonroll company went out of business. So there is a different manufacturer that basically houses the Vonroll name, and when Cedar Point and these particular companies need stuff, they get that information from them. Okay, so if this is your first time here and you have a passion for how amusement rides work, welcome to your favorite new channel. Go ahead, like and subscribe, turn on the bell notifications. I try to release videos about once a week. Sometimes on holidays and stuff come up, I can't do that. But I try to get them out there about once a week, and I cover all sorts of topics across all different types of devices. So let me know. You can always leave me a comment or leave me an email as well if you have ideas of things that you want to see in the future. Okay, so at Cedar Point, the Sky Ride opened up in 1962 in the Midway, right in the middle of the park there at Cedar Point. Now, this is a very scenic installation. My one trip I've made to Cedar Point so far, we did ride it from one side to the other, get a nice little scenic view from right there towards the front gate area to, I believe it was right over there by Dragster where it dropped off somewhere. It's a really cool ride, and it's really nice because it's like, I remember the buckets, as they were called at Great America. I used to go on them all the time. I always had a fear that the thing was going to fall off. I don't know what it was. It was always one of those things, looking up there at that little piece holding you at the top, and I was just like, is that going to hold? Is that strong? What is that? I was very concerned with stuff like that when I was younger. Not so much these days. I really don't worry about them. In fact, when I started working at an amusement park, the state inspector was an aerial tramway inspector, and I asked, I'm like, hey, what are the chances of one of those things just falling off? And he says, you mean like the grip? The grip is the piece on top that actually holds the cable. He's like, you mean like the grip breaking and the thing just falling? I'm like, yeah. And he's like, no, not really going to happen. Not unless there's some sort of catastrophic event where it caused the thing to become mangled. It's like, okay, so a little bit of safety there. I was like, all right, cool. All right, so let's talk about the general construction of these things. All right, so we're going to start with the biggest thing on the ride itself, which is the cable. The cable, and I've done videos about cable. If you haven't seen that video, go back and take a look at it. I spend the entire video talking about simply just steel cables. The steel cable, wire rope, ropeway, whatever you want to call it, The steel cable is one continuous steel band that goes around the entire thing. It does have two open ends to it when it starts. It comes on a giant spool. Now, Cedar Point Sky Ride is only about a quarter-mile long, which means it's a half-mile worth of steel cable. 5,280 feet in a mile, so we'll just round it down and say that there's 2,500 feet of cable in there. Not that big of a deal. You can easily order a spool with 2,500 feet of cable on it. They could order multiple spools and put the cables together, but realistically, every time they do that, it's a very complex process. And when you take the two ends of the cable, and it doesn't come as one piece, it comes as one cable that they have to join. So it comes as a straight line that they have to make back into a loop. When they do that, when they turn around and make it back into a loop, that is called a cable marriage, when the cable goes together. And basically they have to take the end of the cable where it's really nice and tight put together like that, and they have to open them up and then put them across each other and start to weave the cables back into each other. And then what they'll do is they'll cut certain cables out and use the tension of all the rest of the cables to pull that into place. So you basically have two ends that are put together like a Chinese finger trap. They're put together, and there is nothing whatsoever that holds that cable together other than the tension of itself. That's a pretty incredible thing. Now, when it comes to the cable marriage, there is not a lot of videos out there that show how a cable marriage is done, because there's actually only a handful of people in the world that can go out and do cable marriages, because they're a very, very specific thing. So what do we know? We know it's like, okay, you take the cable and you have to take it way back. We're talking 20 feet in each direction, and open those cables up and start cutting cables apart and interlacing the new ones. And then once they're together, you have to start pulling tension on it, and then they have to start basically pounding the cable back into that same spot. When the marriage is done, you cannot tell where that cable marriage was. Now, I'm told that the park, typically what they do is they go out and mark where the cable marriage is. They just put a spray paint line on there. So if you're ever watching the cable go by and you see probably like a white spray painted line pass by as you're in the station, that is the cable marriage. That's where the two cables have come together and officially latched onto each other, and just watch it go by. That's a super interesting thing. The cable marriage is almost twice as strong as the actual cable itself. If you were to put that marriage in a giant machine and pull the cable apart, the cable will break outside of the cable marriage each time. Not right at it, but it will just fail somewhere else, i.e. the cable is weaker than the cable marriage is. So you really don't have to worry about that thing just coming apart once it's done. But it's always interesting to tell people, yeah, nothing's actually holding that cable together except for itself, where it just kind of does a Chinese finger trap together and pulled tight. That's an interesting fact right there. Very interesting. All right, so that cable, now that we've got basically a half-mile worth of cable made in the giant loop, we're going to set that on top of towers. Now, the towers are the big uprights that you see as you walk down the park. It's typically just a vertical pillar that comes off. It's got a T, and then it has two support arms on either side. The support arms are laced with cable sheaves. Now, cable sheaves is like the bread and butter of this ride. They are used all over the place, and they are plentiful. So cable sheaves, what they are is, if you think of a road wheel of a roller coaster, or a guide wheel, or an upstop wheel, something like this, the cable sheave looks just like one of these wheels, except for at the top, it's rubber in the center. It's not a hard urethane. It is rubber. So the rubber actually allows that cable to grip and turn as it goes over. The cable sheaves are not powered at all. They are simply idlers, which means they just sit there going underneath their own weight and rolling along as they do. So typically you have sets of cable sheaves that are put together in 3, 4, 5 wheel assemblies that are mounted hard onto a bracket on both sides, and that bracket is allowed to pivot because As the cable car comes up to the tower, basically the weight of the cable starts sagging down as it comes up there. So essentially, the angle of attack, or the angle up to the tower, is not a constant. Although it looks constant as you're standing there, you could see the nice droop between the pathways. But as you're standing there, you can also watch the car come up, and the cable will start to sag down further and further as the car comes up. Well, if you didn't have those wheel assemblies able to pivot, if they were just locked into place, basically the wheel that's at the farthest end of the tower would take all the weight of that cable as it came up and over. And then what would happen is, as the car came up, it would get onto the top of that, and it would just kind of rock really hard back and forth, and it would do all sorts of bad things that you just don't want. So what they do is they allow that to pivot. Now, is there spring tensioners and stuff in place? Not really. They just sit there. They're free-handed, but the cable, it's able to contour with the cable. We do the same things on water rides when you're talking about belts and chains that have to go up over a crown on the top. For things like an Intamin shoot-to-shoots ride, I have a lot of experience with those things. Basically, there's a big flat boat or a log or something along those lines that has to go up and over a curve. Well, if you put a flat piece onto a curve, the surface area becomes nothing. So it's really easy once it starts to go over that curve for that log or boat just to slide backwards and fall back down. So what they do is they put movable components underneath there that are spring-loaded, so they constantly keep pressure up. So it forms a nice curve, but as that flat piece comes over, it's actually able to contour to the flat boat as it crowns over the top of that thing. So kind of the same thing with the cables. Everything is allowed to pivot and twist with the cable as the car comes up and over. That way it maintains that nice smooth arc as it comes up and over. Now, a lot of people, myself included, were like, do the cable cars detach from that cable when it's going over the tower? Nope, the entire time the cable car is gripped onto the cable that entire time. It never lets go. The only time it lets go is down in the station. We'll cover that stuff in just a little bit. So the towers have a lot of safeties involved with them, and all those pivoting pieces are designed to look for, like, what happens if this goes bad, if a wheel comes apart, if something grabs, if something gets stuck inside of there and the thing starts to twist. Twisting is the worst case scenario in these things. So what they do is, all along those towers, they line them with limit switches. They put a limit switch out on the edge watching it, so the thing's allowed to twist down and allowed to twist up, but they put two switches in line that says basically it's allowed to go from here to here. If it goes too far down, it will trigger the lower switch and say there's a problem, stop. If it goes too far up, it'll trigger the upper switch and say if there's a problem, stop. So this is done in the back or on top or on the side. It's not done around the cable. There are switches that monitor cables themselves from moving. Those are called pigtail limit switches, used on other type of rides. But in this case, since you have the cable car holding the cable, you can't use a pigtail, which wraps itself around the cable and watches for what we call cable hop, where the cable would suddenly jump up and down, basically where the other end has hit something or run into something. You get a cable hop where it goes up and down, it triggers the limit switch and says, whoa, wait, your cable's doing something weird, stop. It's like, okay. But they're not looking for that here. They're simply looking for range of motion of all those components. So there's lots of limit switches on those things. All those limit switches go back to a center wiring bundle that goes down, and they're relayed back to both ends of the towers, or whichever end has the PLC on it. Most of the time, that is the driving end, which we'll get to soon. All right, down at the ends where you load and unload in the station, both stations look pretty much identical to each other, but there are two distinct operations happening in one side and the other. The simplest one to talk about is typically, I believe at Cedar Point, it's the unload station. Well, both of them are the same, really. It's the station that's furthest in the park, away from the front gate. I believe it's closest to Dragster down there. All right, that station down there is the Counterweight station, or the tensioner station. Now, that giant cable that runs over all those towers and comes back down, it's going through the counterweight or the tensioner assembly. The tensioner assembly is just like anything else. It is a giant pulley that is designed to pull tension on that entire cable. Now, the ride tensions itself to some extent, i.e. the more buckets, the more cable cars you put out onto there, the more weight there is sagging down between the towers. The more weight sags between the towers, the tighter the cable gets pulled on both ends. Well, you have to make sure it still stays in tension even with no cars on it. So there is a counterweight assembly in the one station. Now, Vonroll's counterweight system is actually really simple. It's mounted right to the ground. It's got no rollers, no nothing else on it. It is simply a giant wheel on top. Now, in drive assemblies, you have two wheels. You have a bull wheel, which is used to turn and drive, and you have a return wheel, which is going to be this, which is, in this case, this is counterweighted. The same thing on a roller coaster. Your return wheel is typically the one that has the counterweight that pulls tension on the entire chain assembly on a lift hill. Same thing for this particular sky ride. So the wheel sits horizontally in the station, and it has a giant clevis that goes onto the side of the wheel. The clevis has a cable attached to it. It goes backwards. And then Vonroll did something interesting, and it's not something that a lot of other carriers did. But what they wanted to do, instead of taking the cable and going over a return sheave and going down to a set of counterweights, they actually took it and went up and around to the counterweight. Now, a lot of places would have to do this in a couple of different wheels, but Vonroll did it one time. Very interesting. They took a pulley sheave and sent the cable in at the bottom of the pulley sheave and wrapped it around the top and back out. Well, if you look at that in line, you can't do that because the cable would run into itself on the back side. It would come around and then right into itself on the back side. So actually what they did is they said, all right, we're going to take this sheave and we're going to turn it at about a 10-degree tilt. It's not much, 10, 15 degrees, just slightly. It looks just kind of crooked when you see it. But what that allowed them to do is they allowed them to bring the cable in the bottom of the sheave, wraps 3/4 of the way around the top, and then it comes out, but it comes down here where the cable coming in is here. So the two just cross each other like that. Really interesting. And then that goes down to a giant set of counterweights that hang underneath the station and down in this big, basically pit hole right down inside there. Those weights go up around that pulley and grab that return wheel and basically pull the entire cable assembly tight. Now, how often does that move? Not that often. As you load more cabs on it, or cable cars on it, it will cause all the cable to sag, which will cause that counterweight stack to lift up as the cable comes in and it basically shrinks. Over time, they will do nothing but go further and further down because as a cable wears in, the way cables wear is basically the wrapping or lacing of the cable just gets tighter and tighter. As that cable gets tighter, it's actually wearing all of its components down, including its center core. And then that cable gets slightly smaller. The smaller it gets, the longer it gets. So it'll actually that counterweight will start to go further and further and further down until eventually 1 year, I'm not sure what Cedar Point's replacement criteria is, but 1 year the cable will have to be replaced, whether it has worn down and the diameter is too small, or it's simply preventative, which is what most parks do, and they run it off of a time-based replacement criteria, i.e. you sit there and the ride runs fine as long as it looks good. There's no little strands hanging off of it. There's nothing to catch. It doesn't look broken. The marriage is in perfect condition. That can run for a long time, but the park says, nope, it can only run for 5 years. Just made that number up. It can run for 5 years, and then we have to replace that cable. That is time-based preventative maintenance. Because somewhere along the line, they tried to run that to 10 years, and they're like, at the 7-year mark, it failed. Maybe not catastrophically, but maybe it was to the point where, ooh, look, we have to replace that cable now. you don't want to run the ride there. You don't want to say, oh, 7 years, it's like, oh crap, we need to replace it, because that's right close to the edge of failure. So you always say, if it makes 7 years, then let's take a year or two of redundancy on it and say, okay, if it makes 7 years, let's go back and run it for 5 years. We do that all the time in the amusement industry. Like Vekoma Boomerang's 1 year on that cable. That's pretty much it. Some parks can run it up to 3 years. Parks that have had a bad taste in their mouth, which we had, 1 year. We only put 1 year on that cable, and most of the other parks in the system were also 1 year as well. Lift chains. Lift chains are about 10 years. Once you get 10 years on a chain, that chain is time to be replaced. Even if it's in really good condition and it's not stretched out and everything, the engineers just don't have a warm, fuzzy feeling about it over about 10 years. This is a tensioning mechanism that works off of this slide rail at the bottom. The whole machine slides back and forth instead of just the wheel. Okay, since everyone's pretty sufficient now in counterweights, anybody tell me what went wrong at this ride accident? I can hear the comments now. No, this is not AI. Yes, this is real. Yes, this did happen. Anybody? Play it again. Zoomed in. Okay, we'll play this again. Now, top of the counterweight is held on at the very top of this pulley. Take a look at it as it uncoils, and then the whole system comes forward as it's lost its counterweight. And here you can actually see the counterweight cable snap in reverse and fly up against the wall. Alright, so that's pretty much the tensioner mechanism, and the tensioner also has safeties on it to where if it goes down too far, it shuts everything off as well. There, what you have to worry about is it will go either direction. If it goes down too far, you worry about the cable stretching right before it breaks. So you worry about a cable breakage. So if it goes down too far, stop everything, problem. But the other thing you can do is what would be like wrapping the cable. Wrapping the cable would be, for some reason, don't know why, but on your return side, something stops. And on the in-feed side, something jams up. And basically, the drive assembly tries to pull in the cable. It's no longer looping. It stopped on one end for some reason. So it tries to basically wrap itself up, and it starts to shorten the cable dramatically. So that's why the counterweight on the other side is monitored at the top position as well. The same thing, it's in a window. If it goes down too far, problem. If it goes up too high, problem. Everything on these rides operates inside of a window. Alright, so on the other side of the park, or closer to the front gate for the Sky Ride, we're going to go down into the main station, which is also the drive station, where the bull wheel is. The bull wheel is the large diameter wheel that sits up above there and is responsible for transmitting all the torque from the drive system into that cable assembly off over the ride. Now, the bull wheel sits up on top. It does not move back and forth. There is no tensioning to it. It is simply anchored into the ground. Vonroll did a very unusual thing on this particular Sky Ride, and they made their entire drive assembly up on top. This is very unusual. Most rides, what they do, or most aerial lifts, what they do, is they actually put all the drive equipment underneath the station. That way maintenance can get in there and service it and work on it while it's running. They can take measurements, check temperatures, they can grease things while it's running, and they're not in the way of anything. So that's underneath the station, and then there's a large drive shaft that comes up through the station floor, which drives the bull wheel. Now, this is not the case on the Sky Ride. In Sky Ride's case, what they have is all that equipment is up on top, and that is turning the bull wheel directly. So you have the motor up on top, plus the gearbox and the reducer, which is driving the bull wheel all the way around. Now, some bull wheels are driven by tooth and gear, which I couldn't find this out. I apologize. I'm just stepping out on a limb. It's kind of a guess. The way Cedar Point's is set up, theirs looks like a ring and pinion style drive assembly. That's basically the bull wheel has a giant toothed gear underneath it. It's got basically teeth all the way to the outside, and the gearbox has a pinion gear that sits on the side of that and turns. That's what that all looks like to me. Now, I say that because other lift equipment, other Vonroll machines too, also used cables wrapped around the bull wheel. So you had where the giant cable sits on top, and that cable also sits in a rubber groove on both of these wheels. Just like a idler wheel or just like a sheave that's up on the towers, it's like a sheave wheel, just massive and turned on its side. It's got a nice rubber track to it on the inside as well. This is, again, maybe mainly to protect the cable, make sure it doesn't break. But a lot of them had multiple sheaves underneath where they'd use a different size cable and wrap it around the gearbox. So instead of a ring and pinion, it's a smaller cable drive assembly that would go around the gearbox. I thought that was interesting, but this particular model looks like a ring and pinion style drive system up on top of there. Now, there is an electric motor driving it, a gearbox reduction, there is a brake assembly on it so it can hold the thing still, and then there is a backup system to these as well. Now, the backup system varies. Some parks on their sky rides will use a simple motor, an electric motor, with a backup generator to them. On the older ones, Vonroll is an older one, so I can't get the park to tell me what's there, really. But on the older Vonroll models, it was simply a diesel engine. The diesel engine sits there, and it can be fired up, and it will run in the event of emergency. So it's not as fast as the main cable drive is, but it will sit there and it will turn the cable slowly enough to get the people off of there in the event of a power failure or some other type of failure. So there is a backup redundant system to it. And then in worst case scenario where all that stuff fails, in this case Cedar Point would have to take a man lift and go up to each particular one and evacuate the people from there. Which I'm assuming, like most parks, yes, they have that sitting there ready to go. In case they ever need to use that, they have a procedure in place. Almost guarantee you of that. All right, so let's talk about the station itself. If you look at it from the front, the cable going into the station is high, comes in on the high side of it. And if you look just across the way, the cable coming out of the station is low. Why is that? The bull wheel is actually flat on top. It's actually angled slightly to match the slope coming from the towers, just ever so gently. But what happens is that the cable's coming in, that wheel, the cable has to follow that path down towards the bull wheel. Now, what they do is actually get that in just a little bit higher than the bull wheel needs to be, because what they will do is they will lift the coach back up. So as it comes in, the cable car has 4 wheels on top of it. Those wheels essentially land into a track that's sitting around the housing of the bull wheel. And from there, it kind of turns into a roller coaster ride for each cable car, for each bucket. So what happens is as it comes in, the cable car detaches from the cable. Now, it's at a very fast rate of speed. It's almost at a running speed. So what happens is they actually take that and let it go up just a little bit, slightly, and it says, okay, it goes up, and that scrubs off all that speed, and then it levels out. Now, this is where the people typically on these have to catch the car. They literally stand out there and they wait for the car to come in, and here it goes. It's coming down, 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 and then as soon as it comes in, detaches from that cable, it suddenly goes up this little hill and starts scrubbing off all of its speed, and then it starts to level out, and that's when the people will grab your individual car and pull it in the rest of the way, because now it's on a flat level track. And then once they open up the car with their manual key, open it up, let you off, and then they'll now move the car around to the other side to be loaded. Now the other side is the same type of deal, but it's in reverse. This is the reason why one side is lower than the other one. So there, they bring it around and you get in the car. They close the door, they lock it, and then they push it forward. Now at the top, there is a mechanism that is run off of time. On the old Vonrolls, it's ran off of time. So simply sits there, the mechanism holds your coach or your car, cab, whatever you want to call it. It holds it there until the timer goes off. When the timer goes off, it releases your car and lets it roll forward. At the same time, it's got a little arm that sticks down and back that prevents the next car from coming into that. So the buckets can sit there and literally just touch each other as much as they want to. But when that device goes up and says, okay, release that car, a safety goes down behind it and says, wait, stop, the next cab can't go. Don't send the next bucket. And then once that returns down to its lock position, that little lever arm goes back up and allows the next one to roll into the release position. Now this is done off of time. It simply just waits for a bucket to come, and as long as the timer has gone off, it releases it. If it comes in and says, nope, it hasn't been time, it holds it until the timer goes off, then it releases it. Now, on the other side, how we had to decelerate into the station. Hey, I used the word right. Yes. All right. On the other side, you have to accelerate to match the speed of the cable. So you actually get the same roller coaster ride in reverse, but instead of a little hill up, now you get the hill down. So as that releases, now your car actually goes in and it lines up with the cable. And then it starts to go down a little drop. As it goes down that drop, it's actually a very precise angle. It's designed to accelerate your car to the same exact speed as the cable. So as it gets there, it lands on top of the cable. Dead center on top of the cable. And then right when it lands on that cable, it locks to the cable and then goes out on its merry way to the other side. This is a very quick process that happens. It happens in under a second from the time it gets lined up to the time it's latched on and ready to go. Now, there is a little tiny lever arm that sits off to the side of the cable grip, and that little lever arm has to be in a vertical position, if I recall it right, has to be in a vertical position in order to signal that it is locked. If it's at an angle by about 40 degrees, that means unlocked. Vertical means locked. Okay, so now let's talk about the thing that most everybody has questions about. It's a very common thing, and this is going to be the cable grip. Now, I'm going to leave a website in the descriptions down below this video. This is where I got a lot of this information from. This website was very experienced. It had lots of different aerial tramway installations, and it's got a huge long thread specifically about these Vonroll style cable lifts. So if you want to know more about these things, check out the link in the description for this website, because I can't say it. It's a name I can't even begin to pronounce it correctly, but check this website out because it has all this information with detailed explanation of everything inside there. It is absolutely awesome. It's a wealth of knowledge, and even if you want to know more about other cable cars, cable rails, chair lifts, and how they operate, that information is there as well. So extreme amount of knowledge in this website. Go check out that website if this is the thing that you're into. All right, so the next piece we're going to talk about is realistically on the cable car itself. You have where you sit, which is pretty much just an empty container. It's got a vertical support column that goes through it, which is what supports your seats. And then that goes up on the top through a balance bar. That's because you're dead center over the cable, but you can't just lift up vertically. Something has to hold the cable. So it's typically at like a 90-degree angle, holding the cable like this. And those center lines don't match up. And if you moved your carrier over to the center line of that arm, the whole thing would be sitting at an angle like this. It'd be very uncomfortable. So typically they take this arm and just put a balance leg on it. Just a little small balance bar hanging off the bottom like that. So you can sit directly underneath the cable and the thing stays level the entire time. A cable grip is what is actually holding the cable. Is it necessary to hold the cable? I thought it just rode on top of it. Absolutely necessary to hold the cable. Think about your ascent going up to the towers or coming back down from the towers. If the grip on top did not firmly grasp that cable, you would essentially slide down. It would become like a giant slide. You would just slide down the cable, and then you could impact something down below. It would tear up everything. It would not be a good thing. So those cable grips really have to grip. Now, you can go easily onto the internet and find out how a modern grip works, which is typically it's got a big long lever arm off to the side, something like the Disney Skyway over there by Hollywood Studios near those Disney areas like that. They use a modern style grip where it's like you pull the wheel down on one side against two giant springs, and it essentially opens up a clamp like that. So you got one half of the clamp sitting here with the cable in between, and the other half is sitting like this. And then the lever arm and springs off to the side, and as you pull that up, it will basically, or drop it down, I should say, as you drop it down, it releases the cable, and then it's able to come free. Now, Vonroll, this was very early on. You got to remember, these things were designed in the 50s, somewhere right around there. So they use a very unique cable clamp that's not like most others. So what they did was they actually used two halves, both halves move. They essentially sit down spring-loaded in the down position, or where they're open at the bottom, with my two hands like this basically, where they sit down. Then what it does is that as you come down to that cable, the cable goes up into it, and at the same time tries to lift the coach. The cable is now going up, the coach is coming down. So what it does is it forces those two arms to go up, and they snap into the locked position. So once it's in that position, the small little cam goes down, and the arm that was sitting off at an angle basically spring loads and comes back this way and holds the cam down. Now we have locked those two claws in the up position, gripping the cable as tight as it can. Now, because that little lever arm is stuck in the vertical position, it can't unlock because the cam is holding it. So the entire time it goes down, and then the first thing it does when it comes back into the station is that lever arm is pushed off to the side. Now here's where it gets interesting, because normally in stations for cable lifts and cable cars, that sort of stuff, normally what happens is that lever arm is depressed one direction in order to unlock the grip from the cable, i.e. once the arm is pushed down or up, depending on how the thing's designed, that grip opens up and releases the cable. On these Vonroll installations, what's interesting about this is that locking arm is simply just that. It is only a locking arm. So once that arm, you go down to the other side where you're about to get into the station, coming from the towers to the station, that arm has to be moved to unlock the cam. But that does not actually open the grip itself. What they have to do is they have to actually, the car has to start to come up. Remember I said we come in and that car has to come up from momentum. As it's coming up, the cable is forcibly pulled down out of the assembly. Upon pulling the cable down and out, it causes the cam to go over its center point and unlock again. So I've actually got video from this particular website and YouTube channel. So let's look at that video about it going in and unlocking. Really cool, right? It took a lot of understanding, and I had to get into these diagrams that I got from that website and color them to where I could really understand, like, oh, okay, this is happening, that's happening. All right, it goes past the center and it locks up, and then once it's able to be unlocked, the cable is just forcefully just jerked out of the center, which causes the entire thing to unlock, and it stays in the down position until the next time. Super interesting. Like when I got to the cable grip part, I was just like, wow, because I've seen plenty of other animations of cable grips and how they work, and that's not a typical thing these days. So let's move on to storage of these things. You might have seen these where you might have a back area or side areas. In Cedar Point's, they're side areas where they just have these big I-beam looking things going around where other cabs can be stored on there. Simply all they are is it's essentially got 4 road wheels that look like giant pulleys on top of them, and you just simply put a lever down on top of the track that it's rolling on, and you give it an alternate path. So once you're pushing it along, you pull the transfer assembly down on top of the track, and now those 4 road wheels go up onto the transfer assembly, and now it's pushed around to the other side where they can all be stored for offline, whether it needs repair or maintenance, or they're simply just taking them off for the evening. The cable grips that are up on top are removed annually and sent out for service and work, so it's basically NDT work to make sure there's no cracks or anything else like that up on top of there. When I looked for service bulletins for these rides, the main thing that came up was on assemblies that these particular ones for Cedar Point don't have, which is it's lots of cables for opening and closing the doors automatically, which is what you get at ski lifts and things like that. There is simply another wheel and cam device off to the side that as you go into the station pushes the wheel down, pushes on a cable, and causes your doors to open up as you go along. Lots of service bulletins around those, and some for, again, these typically operate in snow. That's what ski lifts are. So there was a lot of stuff about making sure that there was no water inside those vertical columns that were the towers in between stuff, because one place had their tower basically split open, the steel split open down there, and destroyed the tower. Like, it wasn't an injury thing, it wasn't like it fell over, but they were just going out to it one time and noticed that there was a giant crack in the side of it. Water had gotten inside, frozen, so it had pushed the entire cavity out and just torn the steel in half. So they had to put a whole new tower in that place. I think that's enough for this video. If this is your thing, let me know how I did, because this is not the subjects I normally dabble in, but I enjoyed it. It was a fun experience. I enjoyed gathering the information on this and really wrapping my head around how it worked. Again, hundreds of thousands of different installations of these things, and all of them are different, they act different, they look different. So that's why I wanted to focus on the Sky Ride at Cedar Point. But I thought it was fun. Did you have fun? I enjoyed it. Please like and subscribe if you made it this far into the video. You obviously want to see more, so like and subscribe if you haven't already. Give me a comment downstairs if you... Did I get something wrong? I'm sure I did. I've got plenty of stuff wrong in things before. Is there something else you want to see? Leave a comment, let me know. If there's a subject you want to talk about, I'm always open on the email. You can always email me at ryantheridemechanic@yahoo.com. Stay off the air gates. Bye.